Hello, this is Mr. McGovern, and this is the fifth video in the circular motion series where I'm going to look at an NCEA problem. So the problem I've chosen is from the 2020 paper. It's question 2. And here it is. So Joe and Alex are continuing their drive and take a sharp bend at a constant speed of 12 meters per second. So first of all, I look at this problem, and even though it's only part of a circle, it's still a circular motion problem. I don't need a full circle to be analysing it through the physics of circular motion. The first question is asked to draw an arrow on the car to show the direction of the acceleration at this point. So velocities going around a circle are tangent, and accelerations and the forces that cause them are towards the centre of the circle. I always, when labelling an arrow, make sure when putting an arrow in any diagram, label it, because there could be force arrows, velocity arrows, or acceleration arrows, so I make sure I've got a label on it. So that one's an achieved. Question B from this is calculate the size of the acceleration if the radius of the bend is 25 meters and explain what causes this acceleration. So we've got our centripetal acceleration formula, v squared over r. In the previous question, they told us the velocity of 12. Square that, make sure you don't forget to square it, and we come out at 5.8 meters per second squared. So what causes accelerations? Accelerations are always caused by unbalanced forces. And in this case, let's be specific. What is the unbalanced force that causes the acceleration? So in this case, it's the friction between the tyres and the road, and that occurs when you turn your steering wheel. It creates more friction and forces the car to go around in a circle. So that was a merit. I think a mark for the calculation, a mark from the explanation. And then it says state 2 external factors that would change the motion of its car as it travelled around the corner. Explain how these factors would affect the motion. This is a really poorly asked question, and if you actually look in the mark guide, they're only really looking for one external factor, because we'll go through the answer. So what is the difference between external and internal? We're talking about the car, so anything that the car's doing or inside the car would be an internal factor. So an internal factor could be changing the speed of the car. Increasing it means we're going around the corner faster. We'd need a larger force to stay going around that corner. But they're not asking for that, but I just thought I'd put down so you know what an internal factor is. External is something other than the car. And something obvious that could happen is we could get some sort of slippery road, and that could be caused by oil, or it could be caused by ice on the road. And what it does is it decreases the friction force. And therefore, if we don't have that friction force, we don't have anything to provide the centripetal force, and if there's no centripetal force, it doesn't travel in circular motion. So they asked for 2, but in reality they marked on 1 because 2, oil or ice are basically doing the same thing.